Now we'll talk about the vector cross product, and again we'll start with its definition. Much like before, let's assume that we have two arbitrary vectors that could be in 3D. And just like before, we should redraw them so that when we measure the angle between them, we're measuring the interior angle when the vectors are tail to tail. So the cross product here is defined as the product of the magnitudes of both vectors times the sine of the angle between them times a unit vector u, which we'll define in a moment. Notice a major difference from the dot product is that the result here is a vector, not a scalar. So then here, this unit vector u is defined as the vector that is perpendicular to both A and B, and its sense is defined by the right-hand rule. So here u points out of the page. And we get that from the right-hand rule. If you point your fingers in the direction of A and then curl toward B, your thumb will point out of the page. And so from this definition, we can foresee one of the properties of the cross product is that, unlike the dot product, we can't arbitrarily reverse the order of the cross product. Because if we did, then the right-hand rule would say when we point our fingers in the direction of B and curl toward A, u would be into the page rather than out of the page. Of course, the magnitudes are the same, so they would differ by a minus sign. And so here I've written a very useful property, which is that we can reverse the order of the cross product by introducing a minus sign.